I wanted to give you the transcript, the transcription, whatever I say, but sometimes I look like closed caption. Whatever I talk now to you, it's transferred into text. But sometimes something I say, the transcript is very funny. So I'm not just you hear. The main thing is just review whatever I say to you without the transcription. The transcription is very funny. It does not sound very well. So even if you are very good in pronunciation, it's still a problem. So therefore, I'm not just send you the transcript, just the recording. So what is the oxidation number? Oxidation number is a charge that's carried by an element, correct? And this charge called oxidation number. It can be positive or negative. It can be positive or negative. That's what I mean by oxidation number. Now, we have oxidation and we have reduction. Oxidation means the charge carried out by an element will be increased and the electrons will be given away. Valence electrons, the last electrons are given away, correct? So therefore, the charge will go up, will increase. If an element will take in electrons from adjacent elements, this negative charges of electrons will decrease the overall charge on that element, and therefore this element is called to be reduced, correct? Now, let's look at the example here. We have this chemical reaction here. Look at this chemical reaction here. Let me just get this. Let's look at this chemical reaction here. The question is twofold question. The first part of this twofold question is, what is the oxidation number of nitrogen at the reactant side? And what is the oxidation number at the product side of the chemical equation? The second part of the second twofold question is, which of those reactants is oxidizing agent? Which of the reactants is reducing agent? Which of the reactants is oxidizing agent? Which is reducing agent? Now, this will come in the ACS exam, most probably. Should I put it in the question exam? Yes, because this is very, very important. And always you avoid the very strong oxidizing agent. The very strong oxidizing agent will, like a bleach, those will just change the color and then they have more damaging. So, but anyway, so let's look at this and look at the whole thing. Anytime we say, look at this here again. Anytime I have an element by itself or a molecule by itself, those are nitrogen here. You see, nitrogen by itself here, guys. Look at this. Nitrogen here is a molecule, and hydrogen is a molecule. Okay, there is no nitrogen. An atom. Nitrogen is an atom, so it does not exist in nature. Nitrogen comes in nature by combining itself with another atom. They call it bimolecular compound. Bi means two, or dimolecular compound. Bi or di means two. So most of those gases are most of the gases we know, they exist in nature as two. Some of them three. Ozone is three oxygens together. There is no element, single atom of oxygen. So ozone 3, nitrogen is 2, hydrogen is 2, chlorine is 2. So nature will not support an atom by itself. Somebody will tell me why. What do you think the secret behind having those two? Somebody will tell me? Any clue? Well, it turns out if you have an atom by itself, it has electrons by itself, not combined with itself, it will be very dangerous. Highly carcinogenic, will be free radical. Free radical means they can attack the body and causing damage. It can cause tumor and then can develop all the way to cancer, severe cancer, as a matter of fact. So nature is giving us the way to get out of it. So we inhale nitrogen or oxygen inside our bodies, or CO, nitrogen and oxygen. Those are molecules with two atoms. You cannot inhale one nitrogen or one single oxygen. You cannot, because then you have a free radical. They will attack all your body. Just maybe a few weeks you'll live, and then you are gone. It's tumor, and then it develops itself very quick all over the body. Is cancer. So this is a difference between tumor and cancer. Tumor is the beginning of it in one located spot. And then when the free radicals coming out of this tumor attack all the other healthy cells, that will be cancer. So the cancer is the last stages of tumor, and most probably is deadly. So person then advised to live in the hospice. Cannot live at home. You have special houses. You are just waiting to time to go. Correct? Called hospice. You heard about hospice? Hospice houses? Yeah. So yeah, that's what the case. So we cannot have nitrogen as an atom or oxygen as an atom. We cannot. Nobody will live on this earth. Nobody. Yeah, nobody will live on this earth. So since I have this neutral, so the oxidation number of this nitrogen is neutral, correct? So the rule says is 0. So it's the oxidation number, the charge, there is no charge on nitrogen, so 0. Hydrogen here, neutral. I see a charge on it. No, there is no charge. So this is 0. It's a molecule, 0. So this is 0. Now, however, ammonia here, ammonia is different story. That's a molecule, correct? And the total is 0. But 0 for what? This is molecule different, not the same atom, correct? So this one here is hydrogen always +1, except when it's connected to metals. So hydrogen is +1. 3 multiplied by +1, we have +3, correct? Everybody's following me? +3. Now hydrogen will be what? Because this is at the end, it's a neutral. So at the end is the charge on the whole ammonia is 0. So this one has to be what? Minus what? 3. Will be what? -3. I'll bring this one here in the quiz. I think I brought one question in the quiz, but in the exam maybe bring 2. And ACS exam will bring you maybe more than that. So you have to be careful. You got 12, then you go even advanced oxidation reduction in the solution. So this topic will come in 12 as well. It's very important oxidation reduction stuff here. So, and we don't have the secret of this. So if we have the secret of all the oxidation reduction, we can what? Be immortal. We can live forever. Because oxidation reduction is aging. What is aging? It is oxidation reduction reaction. The body, with the cells are aging, means they are oxidized, or some of the cells inside our body will be reduced. And we don't know how is the mechanism inside the body is. We have the cells will be, everyone in this earth will be, or in this universe will be immortal. You don't die, correct? So it's really the oxidation reduction is a very important subject, and we have to know. So we answered the first question of what the oxidation number of all those elements or those molecules. Nitrogen by itself, the first one, is 0 here. Hydrogen and the reactant side is 0. The ammonia in the product side is nitrogen is -3 and hydrogen is +3. Correct? See here, this is the product side and this is the reactant side. Now you tell me if you go from 0 to -3, if you go 0 from plus to +1, what you call from 0 to -3? An oxidation or reduction? No. Decrease, oxidation or reduction means decrease. What will be? A decrease, correct? 0 is here, -3 on your left, correct? -2 is greater than -3, -1 and 0. So I'm a 0 here. My right will be +1, +2, +3. My left, -1, -2, -3, -4, and so on. So -3 is I'm reducing from 0 here to minus 3. Three stages I went back there. So the top from nitrogen is being what? What we call this is being reduced. So this one here called nitrogen is, bear with me, it's very hard with this. Being reduced. How about hydrogen? From 0 to what? To +1. That's an increase or decrease. Remember, 0 is here, -1, -2, -3. 0 is here, +1, +2, +3. So this one would be what? It's increase, correct? So hydrogen being what? Oxidized. I apologize. It's the pen is still a pen is not matching the screen here, the touch screen. So nitrogen is being reduced, oxygen is being oxidized. Now the question is, you put yourself, which one of those, which one is of those, nitrogen or hydrogen? Is an oxidizing agent. Which one we consider the reactant? Which one is a reducing agent? Somebody will tell me. So, well, let's put it this way. In order to figure out which one is oxidizing agent, which one is reducing agent, I go by putting a question. What does nitrogen do for hydrogen? What does nitrogen do? What does nitrogen do in the process? Well, nitrogen is forcing hydrogen to be oxidized. So nitrogen is oxidizing. It's making ing means the one that does the work, the one that does the function. So nitrogen is an oxidizing agent. So what does hydrogen do to nitrogen? Well, hydrogen is forcing nitrogen from 0 to -3 to be reduced. So hydrogen is reducing agent. So in order to figure out, that's even for 12, that's 12. And if you go for higher chemistry or something related to chemistry, you will go for those. Very important to know the oxidizing agent and reducing agent. So what does hydrogen do on nitrogen? Forcing nitrogen to be reduced, correct? So hydrogen is a reducing agent. What does nitrogen do to hydrogen? It's forcing hydrogen to be reduced, correct? One is reducing, one is oxidizing. The hydrogen is forcing the nitrogen to be reduced, hydrogen is reducing. Nitrogen is forcing hydrogen to be oxidized, it's oxidizing agent. So let's look at an example. Let's look at another example here. Let's look at another example. Okay, that will give you a reducing agent. That's the answer. But let's look at another example here. Look at this example. I want you to answer for me the twofold question. The twofold question is, what the charges, the oxidation numbers of each element present, the reactants and the product side in this chemical equation. First, we are looking for the oxidation number. Second one, twofold question is, which one is of the reactant? Based on the reactant, which one is oxidizing, forcing the process of oxidation agent, and which one is a reducing agent? Agent means chemicals. When I say agent, is chemicals. It's a chemical, correct? So let's look at this. Iron by itself here is 0. Neutral, nothing there. It's an atom by itself. It's a metal by itself is 0. Oxidation number, no charge on it. Oxygen, we said those two molecular molecules, they are always 0. But here, now it's changing a little bit. Look at this. So how in the world I know that iron is +3? Well, look at this. 2 multiplied by 3 minus 2. Oxygen is always -2. So oxygen, the sum of oxygen is -6. Correct? So -2, oxygen is always -2, except when it's in peroxide will be -1. So like a hydrogen, always +1, except when it's connected to metal. So this is -6. But you have here 2 of what? 2 of iron. So this, don't worry about the minus. The positive, the metal's always positive. They can't be negative. So, but 6 divided by 2 will be plus 3. Why? Because if I multiply plus 3 with 2, I get what? I get plus 6. So if I multiply the 3 here with the 2 here, I get plus 6. So now plus 6 minus 6 makes what? A neutral compound is 0. Correct? This is 0. So this is a neutral compound, and it's the sum of the oxidation numbers in it has to be 0. So let's look at this now. Now look at this and tell me which is going, although the answer here, but we want to know. Oxygen goes from 0 to minus 2. Is this reduction or oxidation? Here from 0, guys, come on. Reduction, that's minus. Minus 2 is less than 0, correct? So this is reduction. I will say R, so you know this is R. But then you have iron goes from 0 to plus 3. So this is what? That's an increase. So this is what? Oxidation. Now the question is, we answered now. We know the whole, each element would be involved in the reactant side and the product side. Now the question is, which one oxidizing, which one producing? Don't look at the answer. The answer is there, but ask yourself, what does iron do to oxygen? Iron is forcing, correct? Or iron does force, correct? Oxygen to be reduced, correct? Iron is forcing from 0 to minus 2. That's forcing oxygen to be reduced, and therefore iron is a reducing agent. What does oxygen do to iron? Well, oxygen is forcing iron from 0 to plus 3. That's oxidation, forcing iron to be oxidized. So oxygen is an oxidizing agent. Are you following? So it is. Let's look at the other one. Let's look at this. So I gave you all the charges on this. So here you have to do some calculations. It's not really difficult. The whole molecule is not neutral. This is a dichromate, will be going to 2-chromate. Dichromate means 2 chromium ion there in dichromate. So minus 2, and this is minus 2. So ask yourself how we get this is to be plus 6. Well, you have to do some calculation. So the whole charge on the whole dichromate are 207. So this one here, and this one is -2. So what you will see here, -2 is the total, equal to 2 chromium plus 7 oxygen. I don't know what chromium is, but I know oxygen is -2 all the time. -2. So -2, 2 chromium, -14. Why -14? Let me just so here it is, Cr2O7, 2 minus, and you say -2, 2 chromium, -14. Why -14? Because 7 multiplied by -2. Oxygen always -2. So we have -14. Add +14 to both sides. As +14 to both sides. So then you have 12 equal to chromium. So chromium here in dichromate is +6. That's what we got, +6. The same calculation, you can do it for chromium here in chromate. So this is dichromate ion. dichromate, and this is just chromate ion. So now we have all these charges are there. Hydrogen is always +1, oxygen always -2. So let's look at this. So tell me which one is being oxidized, which one will be being reduced. So it looks like oxygen is out of the consideration. Let's look at this. Oxygen is not changing, correct? Let's look at oxygen here. Oxygen is always -2, right? So out. Oxygen is -2, out. Hydrogen is +1, out. Nothing happened to it, correct? Well, it's not true. So we have hydrogen here being changed, correct? So hydrogen is -2. Let me see. If you look at this, hydrogen is +1. Hydrogen is +1. You just get this one, the pen here. Hydrogen is +1, no change. Oxygen is -2, no change. Chromium, this is oxygen is -2, no change. Chromium is +6, no change, and here +6, no change. What's the answer of yours? There is no change in the whole thing, correct? So therefore, this type of equation we have this, correct? Here it is. We don't have any oxidation reduction reaction, and everything no change in order to have oxidation reduction, we have to have change. One will increase, the other one will decrease. But there's no increase or decrease in charges, and therefore the answer is there is no change. So this equation is not oxidation reduction equation. So this is not. So let's look at this. How about this one here? I gave you here to nitrogen is -3. Put this again. Nitrogen is -3. And oxygen, nitrogen is -3. And there is another nitrogen is +3. And here it goes to what? To 0. Hydrogen is +1, not changing. And hydrogen is +1, not changing. So you don't consider hydrogen. Oxygen, take this one out. And oxygen is -2, -2. That's out. That's -2 oxygen here, out. So hydrogen is out because it's consideration. We have 2 nitrogens. One of them is going from, that's a 0 here, correct? One is from -3, because we have 2 nitrogens here, 1 and 2. From -3 to 0. The other one goes from +1, correct? To what? To 0. And hydrogen, we say the nat and oxygen is not changing. So where is the oxidation or reduction reaction? One of them is +3. Is that -3 to 0, and the other one is +3, not +1. Sorry, this is +3. So one of the this is 0 here. So to 0, -3 to 0, that's oxidation. -3 is lower than 0. So that's increase. The 0 is greater than -3. So this is an oxidation. The top from -3 here to 0. But the other one, +3 to 0, that's a reduction. That's from here to here is reduction. And then from here to here is oxidation. Correct? So here you have both nitrogens, but one of them will be oxidizing agent. One will be what? Reducing agent within the same compound. Within that's called disproportional chemical reaction. We will not get into this one here. When you go higher chemistry 12, you will take this one here. But this type of reaction called not single displacement, not double displacement, not combustion, not decomposition, not synthesis or combination. This called disproportional chemical reaction. Why? Because you have one in the middle, one higher, one zero. So you have all this oxidation number for one single atom inside. One lower, one higher, one in the middle. -3, 0, +3. That's disproportional arrangement of an oxidation number. So anyway, don't worry about it. So you can look at the other ones, correct? Phosphorus, elemental phosphorus, the same like oxygen, same element. If you have the same atom, the same element, oxidation number is 0. So chlorine is 0. But here we have chlorine always -1. So you have -5 here, correct? Here the sum will be -5. Therefore, the phosphorus will be 0. So from phosphorus from 0 to +5, this is oxidation or reduction? Oxidation. This is oxidation. From 0 to -1, this is what? Reduction. Now, the answer is here. Tell me which one is oxidizing agent, which one is reducing. I gave you the answer, but you have to ask yourself, what does phosphorus do to chlorine? Phosphorus does force chlorine to be reduced, correct? Everybody's following me? So phosphorus is a reducing agent, does the reduction process. What does chlorine do to phosphorus? Well, chlorine does force phosphorus to be oxidized. So chlorine an oxidizing agent. So I think that's enough. You can look at the other examples. If you have any questions, come and see me. So that's this will follow with you in the 12 more in advance. So okay, now we'll go in the name of the chapter is here. Now we'll start the real calculations. So chemical reaction, we have what we call this type of reaction. I put some types of reaction questions, guys. What type of reaction is this? What's that? Decomposition. Why is this decomposition? This is decomposition here. So decomposition. So why? You have single compound that produce 2 or more compounds or molecules. This is decomposition. The opposite of this, so this is decomposition here, this way. If you go this way, here will be what? Combination, correct? The opposite reaction of this is called combination. Combination means you have 2 or more compounds will come together to produce single compound. If you are producing single compound, that's called combination or synthesis, correct? We have to know the type. Did I put some questions? Yes. It's coming in ACS exam? Yes. Those type of chemical reaction is very, very important. So they will come even 12, those type of reaction types, we have to know how to deal with them. So the only thing in this the beginning of the whole thing is the mole ratio. Those are called coefficients, all mole ratio. So let me take this one here. Okay, this is called mole. All those are what? Those are called moles. Not the animal, guys, not the animals. The moles is ratio of mass over molar mass. So those are called moles, and it has a name for them. If you see in your owl, called, again, can't write it, coefficient. So double F I C I N T S, coefficients. So those are number of moles or number of coefficients. So what is very important, this is in order to resolve some calculations, number of grams. Chemistry is the science We'll always encourage you before you do any mistake or any experiment, you have to calculate first. Somebody will tell me why. You have to calculate how much or how many grams you need from your reactors. You cannot in chemistry blindly or give this, mix them together. You'll be flying a couple of miles in the air and then will come back down ashes or just broken bones. You cannot do that in chemistry. You have to calculate how much, especially if you are dealing with, and that's the problem. That's what caused the explosion. Energy will come out. If the energy come out, you have to know exactly how much. You don't destroy yourself and kill all the other people inside the lab. So there is no, what they call it, crazy chemist. No, because you have to be careful. So that's stoichiometry is going to 12 as well. I'm just telling you that will go with you because chemist has to know exactly how much to add, and he or she can even calculate how much the heat is involved. You cannot just blindly mix this, and then you get your product. You have to know exactly how much you mix so you don't damage yourself and cause damage for other people. So now I say if I have 2 moles of, what's the name of this compound? It's not there, but what's the name of it? And where we can see it, where we can use it. This is called potassium chlorate. Potassium chlorate. Where we find it? We use it, I mean, in some mixture. Clorax. Clorax has a mixture of hypochlorate, chlorate, all this in Clorax, bleach. So potassium chlorate is a bleach, can be used as a bleach. So we'll decompose, correct, to give you 2 moles of potassium. What is this? Potassium chloride, and 3 moles of oxygen gas, right? So, and this is the ratio here. I have 2 moles of the reactants, potassium chlorate, to 2 moles of potassium chloride. I have 2 moles of reactant chlorate, correct, to 3 moles of oxygen, correct? I can relate the reactants to the product. I can relate products to the products, correct? I can relate reactants to react. How about potassium chloride to oxygen? Well, you have 2 moles of potassium chloride, correct, guys? Just bear with me. So, to 3 moles of what? Of oxygen, correct? So this is the relationship between the moles in the reactants and the product sides of the chemical equation. So let's see some examples here. Let's do some examples. Here it is. How many moles of oxygen will be formed from 1.6 moles of perchlorate? Not perchlorate, chlorate. Perchlorate will be KClO4. KClO4. Turn off. Who's calling? Okay, so how many moles of oxygen? Here's the reaction, guys. I hope it's running. So how we do this? Did I put something similar to this in the quiz and the exam? Yes. The exam I did not do, but the quiz, yes. So how we solve this problem? I give you the chemical equation and I'll tell you how many moles of one reactants or the product, and you tell me from the equation what we have. So it's not really difficult. I have given you here 0.6 moles of the reactants. I have this is to begin with. Then I look at what I'm looking for, oxygen. So oxygen will be in the top. I'm looking for oxygen, has to be in the top. Then the bottom has to be canceling itself out. I have to put it in the bottom here, cancel with the moles, not the value, correct? Not the value, but the moles. So then I have this one here, 1.65 multiplied by 3. If you look at this one here, you have, let me just take this one here. So you have out of this one here, you have 3 moles of oxygen to 2 moles of, so 3 to 2, correct? So 3 multiplied by 1.65, that's what's asked, was given to you. Divide by 2 will give you the mole oxygen. Right? That's the calculation. Now, you have to watch for sig figs. So you started with 3 here. So all these 3, the 3 and 2, those are exact values, exact ratio values. They are not part of sig figs. Are you following me here? The same thing with 100%. 100% is not part of our consideration for sig figs. You have to watch for this, please. So 100% is not part of it. Ratio, all exact number ratio, they're not part of sig figs. The only thing will control your results is the one is given to you here, 1.65, 3 sig figs. Your answer has to be 3 sig figs. Now, asking you if they give you 3.5 moles of the you have obtained of your product, potassium chloride 3.5 moles. So it asks you how many moles of the reactants you have to start with. Well, this is given to you, moles of potassium chloride. You look at the ratio, mole of potassium chloride has to be the bottom. Why? Because this unit has to be canceled. If the units are not canceling, then there's something wrong. Setup is not correct. So then you have 2 moles. Look at the equation here. You have 2 moles of this, the reactants, to 2 moles of the product, potassium chloride. So 2 to 2 cancels out, and you end up 3 sig figs. And the same thing here. How many moles of potassium chloride will be formed if you have 2.73 moles of this? You start with 2.73. You have 2 mole of the potassium chloride and 2 mole of the reactant. So this reactant will cancel with reactant. You get the same value there. So, and you can look at this in this one here. Let's look at this one here. Let me take one out. Let's look at this. Now let's look at this. I have here, guys, 2 moles of H2O, give you 2 moles of hydrogen and oxygen. How many moles of oxygen are produced when 1.6 moles of H2O? You start with whatever is given to you. Then you look at the equation. I have mole of H2O has to be underneath. Why? Because I have to cancel the units with the units of mole H2O, correct? I have 2 moles of H2O is here. 1 mole, understood, not written, is 1, with 1 mole of oxygen, correct? You multiply this, divide by 2, give you the answer, correct? Give you the answer. So 630 and then 0.6300, this 0.630. So, and here is the same thing. Here now we are dealing with number of grams. So we are dealing with number of grams. So let's look at this. Number 9, we are dealing with grams. In dealing with the grams, I have to use the molar mass. I need the molar. Whenever gram asked, that's the key here. You have to look at the molar mass. There, correct? There, I was asking moles. So moles, we are not involved with the molar mass, but I need grams. So I start with this number of grams of the potassium chlorate. I have to get rid of the gram, so I have to use the molar mass of the whole compound here, right? This is gram per mole, that's the molar mass. You divide this one here by its molar mass, gram per mole, and you know how to get this one here? Potassium is, when you do the molar mass, you have to do the sum of atomic masses of all the elements involved. So potassium is 23 gram per mole. Of course, 23.0. Chlorine is 35.5 gram per mole. Oxygen is 16, but it has multiplied by 3. 3 multiplied by 16.0 gram per mole. When you add this one here, with this one here. Potassium is not 23. That's potassium. Potassium is 39. Sorry, potassium is 39. Let me just. Sodium is yeah, potassium comes. So here it is. So potassium is 39. Calcium is 40, but sodium is 23. Sorry about this. So potassium is 39 gram per mole. So you add them up, and you come up with so the grams divided by the molar mass. Here's the molar mass cancels out per mole. Now the next step is to get the not the numbers, just the units. Then you can come up here. You have how many grams of O2 will be formed. Then you go for the equation here. You look for how many grams of O2. So then you have 3 moles of oxygen in the top, because that's they are asking for. And I need to get rid of the moles of fluoride, so they are out. And then I need the molar mass of oxygen, O2, which is 16 multiplied by 2, 32. So mole of oxygen, cancels out. So I just multiply this one here. I divide by this one, multiply by 3, divide by 2, and then multiply by 32, and you get the answer. So we have how many steps? 4 steps. Most of the stoichiometry of the within the chemical reaction always will involve four steps. How many? 4 steps. So let's look at the other one. Okay, this is the same thing. Not going through that, but at least you know what type of reaction is this. This is just same thing here. What type of reaction we are dealing with here? This is exothermic or endothermic? This is exothermic. Exo. Why exo? The heat is given off. The heat in the side of the product. If the heat in the side of the reactant will be endothermic. So this is the same example. I'll skip it. So let's go for the other topic. Same calculation. Here is the same number of grams produced, react by a certain amount of grams mass of reactant and product. Well, here we have to be careful. This is the same calculation we did, the same 4 steps we did here. If you look at this, we have to know about the next step is the limiting reactant. The limiting what is the concept of limiting reactant? Limiting reactant, if you have A and B reacting together, correct? One of them will be in excess, too much of it there. One of them in a small amount. So after the reaction, the small amount disappears, correct? And left over from the excess will be there still with you, correct? So the limiting reactant is the concept of a reactant that's being consumed 100%. After the reaction is disappearing, it's converted to something else, not present, correct? So, and let me just look at the limiting reactant. This is just the same equation we did with the chlorate, the same calculation. There's nothing really new about this. You give you the reactant amount, you divide it 4 steps. So all those reactions here, 4 steps. What they are 4 steps? You can write them after me. The first steps is you start whatever is given to you. The number is given to you, whether it's reactant or product. Second step, you divide by the molar mass of the given compound. Second is you divide by the molar mass of the given compound. The third step is to look at the mole ratio. Whatever is asked, number of moles has to be in the top. And the ratio to the number is given to you. So asked number of moles and given number of moles of the compound there. And then you multiply it then by the molar mass of the asked compound. Let me repeat. So first you start with whatever is given to you, the amount in grams, whether it's reactant or product. You divide it by the molar mass of the given compound, whether it's reactant or product. then you look at the molar ratio. The molar ratio has to be, the top of the molar ratio is always whatever is asked. Molecules, whatever is asked, reactant or product. And then the bottom is the one is given to you, so you can cancel. Then you multiply it by the asked compound with a reactant or product molar mass to get the number of grams. So that's the four steps. For the limiting reactant, we have to know the yields of the reaction. The yields of the reactions, you cannot do it unless you know what is the limiting reactants. Well, it turns out to be limiting reactants, I said, is a reactant that's totally what? Disappearing, consumed during the reaction, correct? From there, we can base our theoretical calculation. When I calculate, I say how much if I add of this reactant, how much I get out of this product. As I said, you cannot try just mixing two compounds together. You'll find yourself having an explosion. You kill yourself, you kill everybody with you. No, you have to know to calculate even the heat. So you calculate, I want to use from these two reactants, one is 10 grams, the other one 5 grams. How much I'm producing out of this? So, and then you will see which one is limiting, which one will be consumed 100%, which one will be remaining after the reaction. And furthermore, you can calculate, not this will be in your next chapter a little bit, but in the 12 you will know it more. Calculate even the heat generated, so you don't overdo the things and you get into accident, correct? So let's look at this. We have this combustion reaction, correct? It is combustion reaction. Now, what type of reaction is this? What type of reaction is this? Don't let me down. That will be in the quiz and the exam. What type of reaction is this? Guess what? Combination or synthesis. You are combining 2 or 3 or more compounds or molecules into one single one. That's called combination or synthesis. So that will be whoever in my lab, just watch out for this. I put some question about this as well. So we have to know that of a chemical reaction. So if I have 12 grams of the reactant of hydrogen, and I have, that's the reactant, correct? And I have 74.5 grams of CO. What is CO? What's the name of CO? Carbon monoxide, not mono, carbon monoxide. Perfect. So I have two, this one here goes to for hydrogen, and this one goes to carbon monoxide. So I know the grams I started with. Now the question is, what is the limiting reactant and what is the theoretical yield? The theoretical yield is amount, how much I will obtain based on the smallest amount of the reactants being consumed 100%. So based on the limiting reactant. So let's start with CO. I'll determine number of moles and then I can tell you a number of moles. So let's look at this. I start with CO, carbon monoxide, 74.5. That's step number 1. How many steps I will need? Here I don't need grams, so 3 steps. If you don't need the grams, you don't go further. Just 3 steps. If you need the grams, 4 steps. This is number of moles. I need just number of moles. The least number of moles will be my limiting reactant. Let's look at this. 74.5 grams of CO, correct? Then I have to have divided by smaller mass, correct? Divided by smaller mass, that's given. Divided by smaller mass, carbon is 12, oxygen is 32. Add them up, 28. And then I am getting how much I'm getting number of moles of the products, methanol out of carbon monoxide and hydrogen. So I have 1 mole of this to 1 mole of this. That's the ratio here, correct? 1 mole of the product to 1 mole of the reactants monoxide. So I'm getting what? I'm getting 2.66 mole of methanol, correct? So now I do the same thing for hydrogen. I have 2 grams of hydrogen. Then I have 1 mole of hydrogen to 2 moles, correct? 2 moles of hydrogen. 1 to 2 moles of hydrogen. So mole of hydrogen cancels the mole of hydrogen. And then I have 3. So which one is limiting? Which one is the least? 2.66 or 3? 2.66. So therefore, the molar mass is less. So carbon monoxide is our limiting reactant. And hydrogen is said to be, to have a limiting reactant, you have to have a stress reactant. Limiting means consumed 100% during the reaction, you're not any CO2, CO, carbon monoxide present. However, you will see part of hydrogen, correct? Somebody will tell me how much is hydrogen will be after the reaction? How much? How much? At least. From the products, you can tell, this is, you can tell 3 minus 2, that will give you number of moles of the, of what? Number of moles of the product. The difference between number of moles of the products and hydrogen, always half of the moles present, correct? So divided, whatever the subtraction, divided by 2 will give you the leftover hydrogen after the reaction is done. So now, this will be, look, this one here is limiting. I will base my calculation. This will be the least limiting reactant, correct? Calculation. So I did this one here. And this one will be I'll calculate then my theoretical yield. Did I do any experiment? No, I did not do any experiment, just calculation. Therefore, called theoretical yield. So the theoretical yield is based on the least number of moles. If I have to go further, because I cannot weigh moles, correct? So I go and multiply this by the molar mass, molar mass of ethanol, where carbon is 12. I have 4 hydrogen and 1 oxygen. So 20, and this is 32, correct? If you look at the whole thing, is 32. So if I multiply this one here by 32 gram of the product per mole of the product, so the product cancel moles out, and then you have to multiply this number of moles by the 32 grams from the molar mass of the product, you get number of grams. So if you look here at the next one here, so everybody's following here? Everybody's following? So now if you look at this, I have to multiply this by the molar mass, as the same thing I did this one for you, the calculation. So here it is. This is the molar mass of methanol per mole. So the mole cancels with the moles. You get number of grams. This is the theoretical yield. This is what? The theoretical yield. Now, if I do an experiment, for example, and suppose I got, after this experiment, actual experiment, 30.5 grams. This is after the experiment. So this will be after experiment, correct? So this will be my actual one. Actual. So I call it actual or experimental. Actual or experimental. Now, the overall yield then will be actual over the theoretical multiplied by 100. Actual is less divided by the large number, which is the theoretical value, multiplied by 100. But sometimes the students will have, for some reason, they are rushing in the lab. They are not drying their products, and they get the theoretical value 100 over 100, 110. Correct? You cannot, if your limiting reactant is 80.5 grams, and you get 100 grams of your from your experimental, that's something wrong in the experiment. The experiment is, the material is not pure. It has something inside, makes the value hit more. So actual always, if you work in the lab and calculate, your calculation has to be more than the actual. The actual, because you do the actual experiment and you lose some of the material, the processes, filtration, distillation, gravimetry, titration, reading the balance, reading the purettes, pipetting. All those errors will give you the actual yield always less. And if you take the actual over the theoretical, multiply by 100, you get what? You get the overall yield, percentage yield or overall yield. So, and here it is. It's given to us here. Look at this. Now we have this. This is the theoretical, say T, theoretical. And this one here is the actual. It's asking about the yield. So the percentage yield will be actual over theoretical. And the whole thing is multiplied by 100. The whole thing is multiplied by 100%. So take 0.500 gram divided by 85.1 gram multiplied by 100 will give you the actual yield. Now I'll ask you one question. How about the percentage error? So you started with the theoretical value. This is your 100%, correct? But then you'll not get 100%. What is the percentage error? This is your 100%. But this is the actual one, which is less than 100%, correct? This is the overall percentage, actual over theoretical. So what is the error of the yield? So it turns out to be, somebody will tell me, the error, how close you are from your, we have precision and we have accuracy. So if I know the actual value, that will be accuracy, not precision. Precision, if you repeat the experiment and get a couple trials, and you take the average of a couple trials, that's precision. So take the theoretical value, subtract your actual value from the theoretical value, divided by the theoretical value, and then the whole thing multiplied by 100. So just to let you know that in this chapter, you need really to have a flashcards and plenty of them. You have a lot of formulas. So be generous with yourself because you cannot leave your chair and get some papers or some materials. You cannot. So in order to take this exam, please have all the formulas you need. In the OWL, you see a lot of formulas as well. This is the same formulas anyway. But you need those formulas handy to solve those problems. Without those formulas, you will never be able to. So what is the overall yield? The overall yield is theoretical divided by, actual divided by theoretical multiplied by 100. What is the percentage error? Theoretical minus the actual divided by the theoretical multiplied by 100. Now let's look at the example here. This is an example here, and then I will stop because the other stuff, don't worry about it. That will come later on in the titration and everything. But this is the last example, which is very important. So we have CO2 produced, the amount of, that's an example here. This is a propane, correct? It's combustion reaction, pure oxygen, reaction of pure oxygen, combustion, give you CO2 plus H2O. If you use of the propane, that's a gas, similar to natural gas, always comes in the nature combined with methane. So you can buy propane, you can methane. So propane is this one amount of grams reacting with this amount of oxygen. Calculate all those here, amount of moles of CO2, theoretical yield, overall yield, percentage error yield. This is by far those two slides, this slide and the slide before, this example here, this slide here, this reaction, and this, you have to print them out, or you have to do something. There are some calculations based on this. So you have to know them exactly. So first of all, how to get the number of limiting reactant? Well, you start whatever started with you. So CO2 is this amount, started with this amount here. So CO2 starts with this amount, always given to you, divided by its molar mass. Then you see the mole ratio from the equation, 3 moles of CO2. The equation is here in the top. I can show you the top. 3 mole of CO2 combustion reaction to 2 mole to 1 mole of that's the product or the reactant. You get product CO2. You get this number of moles. Then you go, and I give you the molar mass of both here. Then you go here and the number of CO2 moles based on oxygen. Oxygen is this grams divided by its molar mass. You go to molar ratio, you have 3 moles of CO2 to 5 moles of oxygen. So it's this. So now you tell me which is the limiting reactant, which is smallest one, 0.01 or 0.03? 0.01, correct? So this is oxygen is the least number of moles, correct? Produce the product with the least number of moles. So oxygen is our limiting reactant. So we'll base our calculation on oxygen, which is 0.103 moles, and then we multiply it by the molar mass of the product. That's produced from the limiting reactant calculation. You get number of moles of the product is this. Now, this will be your theoretical yield. This is your theoretical yield calculation. You did not do anything. You did not do experiment. Now, after the experiment, correct, you get this one here. After the experiment, it is 0.550. Always remember, if you have done very good job, the actual always less. You cannot get over the actual, the theoretical. So you divide this one here by the theoretical. This is a theoretical here. Multiply by 100. It came out your experiment is very, very good, 96.2. Multiply by 100, that give you the percentage, correct? That will give you the percentage, which is 96.2. Now the error is theoretical, correct? Which is the theoretical came out somewhere. The theoretical is this. Here, this is the theoretical here, minus the actual divided by the theoretical, multiply by 100, give you this amount. So your error is 3.86, which is very, very, very good. You did excellent job in experiment. Bad experiment, if you exceed 25, 30%, that's a big error. But you have 96.2 recovery. That's excellent. That's really very good. So 96.2 recovery, which is really excellent. Excellent job. So we'll not go through this titration, but at least it's worth to just to look into it, because we have a couple of minutes. We can go through this titration. We'll come back in 12.12 in details. So this is a 12.12, but I wrote this here and then just to show you how important this titration. Titration, you need a purette, you need an Almar flask, and the purette is read down from the top to, so start from 0 to 50. The upper part of it here is dead volume because it's not calibrated. So here it is. So this one here is not calibrated, called dead volume, dead. It's not calibrated. So, but start from 0. So 0 and to 50. Now, so 50. This one here, this area called dead volume, it's not calibrated. So if you run your burette all the way beyond 50, and forget about your data, your results not correct. And if you go above 0, your data is not correct either. So you have to be between 0 and 50. Only that's what burettes read. What's unique about burettes? Burettes very expensive because they're highly calibrated glassware inside our labs, inside most of the labs. Now this is obsolete, of course. If you go CVS or Walgreens or Walmart, whatever, I mean, pharmacies, they don't use this anymore. They use automatic one, very fancy one, automatic one, which is much more accurate than the glass. You set it up to the amount and you just let it go. So much more, it does not depend on your eyes, which is very important for drugs. You prepare generic drugs in the back of the pharmacy. You cannot use your eyes. And if you are tired, you read something wrong, you might kill a patient, correct? Give that patient the wrong drug the wrong mixing. That's not good. So, but this is still used in the labs, even research lab. But in the real life, they use much more advanced one. They call it automatic. And sometimes even now I heard about even electrical. Now, in the titration, the acid-base, titration means the reaction of acid-base reaction. Acid-base will consume itself with the base. And we have two steps. We have two types of equivalent. If the titration, we have equivalent point, correct, here, and we have titration endpoint. Well, the titration endpoint, we have 3 minutes, but just to show, that will not come in the quiz because this topic is 12 topic. But I just added in the book just to get students the sense of the next step in 12. This is a very intensive chapter in 12 about titration. So this one here, you have to use what? Indicator. Okay, guys, use what? Indicator. So here we don't use indicator. Here, the endpoint here, you use what? Calculation based on this number of moles. So moles of acid equal number of moles of base. Okay, guys. So this is the difference here. The titration endpoint, you will see it when the indicator changes its color, whatever color, orange, then red, orange, or red, yellow, whatever color, then you spot this one here. But as a matter of fact, titration with the eye is not really recommended because it's an error. Because although the error is very small, it's a negligible difference between the two volumes, but still there is an error. The best thing is the automatic one will give you the best one. Even the electrical automatic one will give you the exact where is the equivalent point. Will not give you titration because you don't use indicator. See it in the eye. The instrument will give you where is the equivalent point. And that's exactly how many moles of the acid react with how many moles of the base. As I said, I did not put this one here in the quiz. Will not come in the quiz, will not come in anything. Here's just how you separate those ions. We did this we did this one here in experiment number 4, correct? You decant after, add some solvent, you decant them, and then after decant them, you heat. One of them will stay in the bottom, then you just make filtration. And this is the vacuum filtration we did this Monday. Last Monday, that's a vacuum filtration, and we did it for the copper. Remember the last step? So, and those, that's just a calculation we did before. I will stop here, and then the quiz is already on. Please do not attempt it now. Do your owl, and you have any question, just email. Last day will be the 13th. 8 days. But if somebody needs extension, or if you need extension, I can push it to. That will be Tuesday. I can, or what today is Wednesday. I can push it to Friday. If there's on demand request to push it to Friday rather than Wednesday, I will. Okay. So good luck, and please do your owl because this is coming from owl question from the test bank. Pick up one of the
Yeah, he said the due date is now over.
Yeah, that's it. I'm too old.
Oh, wow.
Thank you. What's that? You lost the wallet? Found it? Okay. Oh, your backpack? Okay. That's fine. That's good.